Chapter 1, all about the scientific method. So we're going to go through the different steps of the scientific method using an example or two. We're also going to talk about different scientific thinking methods. So things like biological literacy, why that's important, the different parts on the experiments, why it's important for you to know those, and some different important things like pseudoscience and anecdotal evidence, things that you may not be aware that you're seeing in the news and so forth, and to be aware of. So what is science? So we talked on the first day of class that biology is the study of life. Science is the study of natural phenomena. And most people think that science is like, this body of knowledge, these books, lists of facts to memorize and so forth. But actually, that's not what science is. Yes, that stuff is there. However, we got a lot of that information because what science really is a process. Science is the process of observing, describing, experimenting, and explaining those natural phenomena. So anything that's around us is, going to be able to be observed and so forth. And it's a path for us to be able to discover and better understand our world. Now, we're going to be focusing on the study of life in this course, but obviously there's lots of different sciences. We will be seeing some of them. So we're going to be seeing chemistry. We're going to be seeing some physics, because all of the sciences are tied together in order to explore. So one of the things that you may have come across is on packaging, like this box of cereal, it's Cocoa Krispies, things like this. Help support your immunity, or, will help you with a cold, things like that. And so how do you know that's true? Can we trust packaging claims that companies make? And that's where scientific thinking comes in. Scientific thinking can help us put claims to the test. And in fact, it's actually helped change some packaging and changed packaging rules, because some of these companies have put things on their packaging that actually were false. So this is where scientific literacy comes in. So what is scientific literacy? So basically, it's how to think scientifically. So when you see something like a claim, like it boosts your immunity, you can think, well, why are they saying that? What is it that may change my immunity? It's not like, they can put a vaccine in that cereal. So in that case with the cereal, it may be something like, vitamins. We know that we need vitamins for our immune system. So are the vitamins there? You can do a little research. So that's the thing, is that you can start thinking scientifically, figuring out where to find that information, and then how to use the knowledge that we gain to make wise decisions. Should you take those medications that are making these claims? And, should you, consume different foods and so forth? And the thing is that the scientific literacy is becoming increasingly important in our lives today, especially related to biology, because there's lots of new technology coming out. We're going to talk in this course about things like GMOs, genetically modified organisms. There's a lot of new technology around a new genetic manipulation tool called CRISPR. That's going to be huge as far as technology goes. But also, you guys have probably seen things like this, right? There's lots of stuff going on right now about the climate. You've got things like 23andMe and Family Tree and all of these DNA kits. So if you do one of these, what does that mean? What are they looking at? There's all kinds of science and things in our popular media and in our movies and things like that. So if you understand some of the science and understand scientific thinking, actually some of that's more interesting and fun. Also, when you see things in the news or your doctor tells you about something, you can start to think about information that you figured out or figure out where to find the answers. So we're going to be talking about things like saturated versus unsaturated fats. We won't talk about it in this course, but what are allergies? Why do they strike children from clean homes more than dirty homes? That's related to things like immunity. We'll talk about agricultural pests. Why do they appear faster than new pesticides? Things like all of these things are related to biological and scientific literacy. Understanding how these things are working at their base is incredibly important in today's modern age with all kinds of information coming out. So biological literacy is your ability to use the process of scientific inquiry, the scientific process, to think creatively about real world issues. So, are you able to apply this scientific thinking, this, questioning using the scientific method and scientific thinking about what you're hearing every day in the news? Then you communicating those thoughts to others. So can you, ask those questions and send that information to other individuals? And then integrate that into your decision making in your everyday life. We're going to talk about vaccines. So finding out some of this information about vaccines, does that, you can apply that to your own life. And I'm not a medical doctor. You definitely want to talk about these sorts of things with the professionals as well. And that's the other part of biological and scientific literacy, is knowing who the experts are that have spent their time learning about these different fields and specialties. All right, so the scientific method, how do you think like a scientist? So how do you learn how to, think scientifically? Well, the thing is that you already do this, but we're going to take a look at it a little more closely. Like I said, you've probably seen this before, but we're going to take a look step by step through the scientific method. So we're going to go through all of these different steps and see how they work. The thing is, with scientific thinking, it's empirical. This means that it's based on experience and observations and not just on feelings and, general thoughts. So this is based on the experience and observations that are rational, meaning that they are logical, testable, and repeatable. This right here, the last two, are the biggest parts related to scientific thinking and testing. You have to be testable and repeatable. If you can't do this, then there's no point in continuing to look at it. If you can't test it and repeat it, if you can't see it again, then it's not going to be something that will be integrated into scientific thinking. So for example, eyewitness testimony. We'll talk about this a little bit more when we get to talking about DNA. Thing is that we've used eyewitness testimony in our courts for over 200 years. But the thing is that we know from using scientific testing and scientific thinking, we've evaluated it. It's not going to be something that is very reliable. And scientific thinking is self-correcting. So if we continue to test something and then we find new evidence, we'll apply that new evidence. We'll apply that new material to what we've been testing and reconsider those ideas.